Okay, hi, my name is Jimmy Wang, and today I'm going to talk about the React Virtual DOM. Before we get into it, let's first go over just a little bit about the real DOM, which is the Document Object Model. It's an API for interacting with documents such as HTML and XML. It's a method of representing structured documents via objects. Okay, so basically the DOM provides an interface to traverse through and modify nodes. It contains elements such as like get element by ID or like remove child. And then whenever we want to dynamically change the content of a web page, we would modify the DOM. So, okay, what are some problems? So like the DOM manipulation is like the heart of like the modern like interactive web. Although it could be easy to traverse through a DOM tree. The time it takes to do so is the real issue. Although it's not like technically slow because you could change things on the spot. What's slow about it is like the process of just like this laying out elements and painting them for the users to view. Okay, so the slowness is made worse by the fact that most like JS frameworks update the DOM more than they have to. So every time the DOM changes, the browser needs to recalculate the CSS, do layout, repaint the web page, and like that takes time. So like an example that I have is imagine a list of just like a grocery list of 20 items, and we want to insert an item into the list. So how normal frameworks traverse is they would actually re-render the whole thing while only having to make like one particular change. So like they would rebuild the entire list, and in this case it'd require like 20 times the work to do so. So like one item would change, but everything re-renders, and everything that doesn't change gets rebuilt exactly the same way. Rebuilding the list is not a big deal for the web browser, but modern websites that contain huge amounts of data therefore requires like huge amounts of like DOM manipulation. So like again, like the DOM tree is usually quite large, but there's style sheets that needs to be applied to every possible element. So the rendering could take a lot of time. Okay, so a couple questions that I want to think about when going over the React Virtual DOM is when do I re-render and how do I do so efficiently? So because the DOM tree is quite, so like the browser, so like browser makers are like continually working to shorten the time it takes to repaint the screen. The biggest thing that can be done is to minimize the batch of DOM changes that makes redraws necessary. The strategy of reducing and batching DOM changes taken to another level of abstraction is the idea behind the React Virtual DOM. Okay, so before we get into React Virtual DOM, let's talk about what is a virtual DOM. So React actually didn't come up with the idea of virtual DOM, they just popularized it. It's basically just an abstraction on the HTML DOM. It's lightweight, it's detached from the browser-specific implementation details. The idea is to use the real DOM as little as possible and make changes only to the places where changes need to be made. Okay, so, oops. Okay, so yeah. So in other words, the virtual DOM is just an abstraction on top of an abstraction, which is the regular DOM. Okay. Okay. So let's talk about React. Okay. So the React Virtual DOM, basically it's event-driven, responsive to state changes. What makes it unique is its fast and efficient diffing algorithm that basically finds the minimum number of operations required to update the real DOM. Okay. So in React, for every DOM object, there's a corresponding virtual DOM object, and a virtual DOM object is just a representation of a real DOM object, like a lightweight version of it. Manipulating the DOM is slow, but manipulating the virtual DOM is much faster because nothing gets drawn on screen. It's like the exact same thing, but doesn't have the capability of rendering what's in front of you. Yeah. So again, like centerpiece of virtual DOM is the diffing algorithm, which once the differences in the model have been like mapped in memory, the DOM finds the minimum number of operations to update the real DOM. Okay. So React's answer to the questions so when do we render when the data being observed is dirty, and how do I do so efficiently? It's just using the virtual DOM to generate a real DOM patch. Yeah, so like, okay. So React's render method basically creates a node tree from React's components and updates this tree in response to mutations in data model caused by like action or like changes of like state. If nothing changed, then we don't do anything, and if it does change, we know exactly like how we want to like update something. Yeah. So in React, like the components have state, and React essentially knows how to re-render the scene because it's able to observe how the data changes. Okay, so yeah, so let's go. Okay, so yeah, so this is when React renders, creates like a version of virtual DOM, and okay, so yeah, so when React UIs renders, it first renders into the virtual DOM, which is not an actual DOM graph, but it's a lightweight pure JavaScript data structure of plain objects and arrays that represents the real DOM graph. And then, yeah, so whenever something changes, it's able to track whether if like an element is dirty or not, and it's able to use its like diffing algorithm to render the appropriate elements. Yeah. Okay. So basically, in short, okay. So when the state is changed, React compares the virtual DOM with a virtual DOM snapshot of like the previous state that was taken right before the change. It compares the new DOM with the old DOM, figures out exactly like what DOM objects have changed, and then this process is called diffing, and then in doing so only renders the changed objects and only those objects. Yeah, so it'd be like smart enough to like rebuild the one changed product on like the grocery list. Yeah. Okay. So we're gonna go into an example. We could actually create like a very basic version of our own virtual DOM. It's actually right around like 50 lines of code, and yeah, so we're gonna go through how like that algorithm would look like. Okay, So key points, so like the virtual DOM is, again, is just a visual representation of the real DOM. When we change something in the virtual DOM tree, we get a new virtual tree. So the algorithm should compare the old tree with the new tree, and then only make the necessary changes to the real DOM, so that it reflects the virtual. Okay. I lost my notes. Okay, so first we need to figure out a way to store our DOM tree in memory. Okay, so we could do that with like plain old JavaScript objects. Suppose like we have this tree, so basically we have a parent component, parent, which is the unordered list, and then we have some children, which are like the list items. And then, yeah. And then that can be represented as a JavaScript object. Okay. So this would be the way we could represent how this particular creator function would look. It's very similar to a function that we all know, which is the React create element. Basically, it takes the type, it takes the attributes as a second argument, and then as the last, it'll be like an array of like all of the children. So yeah, so if we could just replace the React create element with our DOM object function, we could begin building a virtual DOM, and we actually can do that by using something called JSX Pragma, which just allows us to use Babel and Transpile. Okay. So yeah, so we just need to include a line like that in the top of our source file, and then so basically it'll go from what looks like JSX, HTML, gets transpiled with Babel to our DOM object function, and then returns an actual like JavaScript object representing the DOM. Okay, so now we're gonna write the actual create the diff algorithm. So assumptions like all variables that represent DOM nodes will start with the $. Virtual DOM representation will be named node, and then similar to React, there will be one root node with all others inside. Okay. So this create element will actually take the virtual DOM node and return a real DOM node, because we can have both text strings and also elements. We'll check for the condition, return a text node, or else we'll create an element with the type. Yeah. So. Oh yeah, right. Okay. So now let's think about children. So like each of them is either a text node or an element, so they can be created with our create element function. So we're just gonna, if a particular node has children, we're just gonna map through each element in the array, and then we're gonna recursively call create element on these children, and then append it to the parent node. Okay. So the diffing algorithm. So there's 4 cases or conditions we need to test. One of them. Okay. So in short, so there's 4 cases we need to test, and then so we need to add, remove, or replace check changes or add. Yeah. In short, I'm gonna skip to what it'll look like at the end. Basically, so basically, it checks to see if there's an old node in the first condition. If there's not, then we just append it. If there's no new node, if the new node is different, we're gonna remove the child. It'll check for a change and replace, and then the last condition recursively iterates through all the children. And just want to show that code executed real quick. So basically, I have JS Fiddle. I made the list. and I'm going to change the list from soda, fruit, and bread to soda, bread, milk, and cookies. If I hit reload, the only thing that should change are the list elements. So, yeah, that's it. That's the presentation.